how grids look at. So if you start from the left and you go to the right, these shapes represent numbers. So on the graphene, those is little substrate. It's really hard to find, so we go by, from the left is 0, and then it goes on. So this would be 0, 1, 2, 3, and so forth. So this example right here, from the left side coincides to the row number, and the right side to the column number. So for example, this marker shows the 3rd row and the 12th column. 0 and 3, 1, 2. Basically, a process to apply graphene to samples. After samples have been exposed to the graphene, we repeat the cleansing process. Again, 10 minutes in acetone, 10 minutes in methanol. Rubbing with the tape. That's the exfoliation process, also known as the Scotch tape method. When it's applied to the actual wafer, you'll see that you have this residue right here. Those is not actually the actual graphite. Those is actually residue. So it goes through a process of annealing, which is like a cleansing process. So as you can see, previously, you have all these kind of residues, but after annealing, the residues it disappears. It just makes it easier to identify graphene. Next, output measurements is made. We start off by searching for graphene under the microscope. Right here is a picture of graphene in 20x. As you can see, it's hard to see. It's basically because graphene is nearly invisible, so you really have to go deeper. So right here, 50x. If you notice, as you go closer, the image becomes better to see. But it's hard to see because it's almost invisible. But it's a thin piece right there. Then this is a piece in 100x. Basically, this is identifying graphene. Right here is the graphite below graphene. And you can see small pieces like this, like the tell. It's hard to demonstrate or find graphene if you don't know what you're looking for. When I first started, it was hard for me to find graphene. I was under the microscope for hours. I don't see nothing. But it was really something there. Raman spectroscopy is just basically, at the top is the substrate. That's the sample that we use. From this graph, you can see the graphite. You see these 2 peaks. It's higher than these peaks. Let's just identify that is graphite. If you move down, you see that the 2 peaks from the graphene is higher than the peaks over here. So basically, you would know you will find graphene when the peaks are higher for graphene than the graphite, and when the graphite is higher than graphene. Making probes, these are some of the patterns that are used to make electrical contact to the actual graphene once found. This is an optical image of the device. If you could look, this is a close-up of graphene that was identified, and this is the electrical contact that was made to that graphene. Right here is SEM images of some of the devices. Once images are taken and contact is applied, we start our process all over. Many samples were taken but not clear. Differences have been seen. We have not been able to come across too many good pieces of graphene. The process will continue. These are my references, and I would like to thank Dr. Jonathan Bird, Girish, Ann, and Ms. Cup Owens and the CSTEP family. Questions? Matt, you good?
You said it was just the graphene discovered by cleaving?
Yeah.
What is
Cleaving is just basically another way of saying the Scotch tape method. Cleaving is basically the Scotch tape method, but that's what it was called in 2004.
And why you actually use it's a piece of Scotch tape and go back?
You know the actual Scotch tape that you buy from the store?
Right.
Basically, let me go back. It's the actual Scotch tape. It's like no special Scotch tape that you can use. It's like the actual Scotch tape that you would use like for anything else. So basically, you just alright. So right here, right. This is the wafer, like the substrate, what we put it on. So basically, the Scotch tape, you apply it to the graphite. Then you take another piece of Scotch tape and you rub it together. And once you stick it and you pull it off, like it's like showing you. It's basically shaving layers. So then you just keep basically going until the Scotch tape gets dirty. So the more you go over the actual piece of graphite, the thinner the layers you're getting. So that's the closer you're getting to graphene. Okay.
So the Scotch tape method is the same Scotch tape that we use in the office and say stick on the tape when you see
The same exact Scotch tape. Anyone?
How many times do you have to apply the Scotch tape before you actually?
Well, it's funny. Like, all right. So basically, you have the Scotch tape, right? So when you first put it on there, it's exposed to air. So anything can happen. It could get dirty. So basically, what we do in the lab is we apply the Scotch tape again. So when we apply the Scotch tape again, that's like the Scotch tape that we have, like the one that we originally made. We put that to the side because it was exposed. So it could take, basically, we take the Scotch tape is about this big, and we just keep applying it until the whole Scotch tape is dirty. The graphite, once it's applied more than one time, like you'll just see all the tape just getting dirty and covered. But it could take, depending on how big your piece of tape is, it could take 5 minutes or 3 minutes, 4 minutes. It depends on the size of your tape.
You said graphene is hopefully going to be a replacement for silicone?
Yes, scientists says that it could be a replacement due to its flexibility and its strength, like basically, as far as a dual replacement.
Will it be less expensive than silicone?
I'm actually not sure, but I know that it will. Silicone devices are getting smaller and smaller, and silicone, I know, can't keep up with how small the devices are getting. So that's the only downfall for silicone. We're on the verge of taking that over. Any other questions? You have a question?
I was going to ask the same thing, how big is the beginning pellet and how much Scotch tape it would take? But more so, why is this significant? What is it used for?
What is what used for?
What will it be used for?
Graphene.
You made reference to a great telephone or something.
Oh, I was just saying that, basically, electronics change every day. They're not getting bigger. When you first started using cell phones, they wasn't the cell phone little Palm Pilot that you have now. So basically, as the devices or electrical devices is getting smaller, silicone cannot keep up with that device. So to make things go faster, graphene, like transistors and stuff, graphene is like being looked at as a replacement tool. So soon you might be able to have a phone in your ear. Like you won't even know. Like it's that serious. No other question?
I'm sorry.
Oh, I'm sorry.
When you actually strip down the graphite to graphene, what do you then do with that graphene? I know you said the process started from over.
Okay. So basically, once you're confident in your piece of Scotch tape, you apply it. Like you take tweezers, and it's a little a wafer or a substrate, and you rub it against the back of it to apply it on. So and then after that, then we bake it, then we clean it. That's how we get it.
The Scotch tape versus the graphene?
No, the Scotch tape is just the method that we use to get the graphene on the substrate. That's it. That's just a common method that's used. That's like a good way to produce it.
She got a stack.
Let's go, Priscilla.
Oh.
Quantum leaps.
Good afternoon, everyone. Today, my presentation will be on the synthesis, characterization, and evaluation of chitin